fun. Last year we had Michael Jäger from Canonical here with us. He was a former Siemens employee, and he told us, hey, I have some other cool guys doing fancy projects. And so we have today Jalton and Konstantinos. Stage is yours. Thanks a lot, guys.
Thank you. So it is a very nice way to start when someone is calling that you are a cool guy. So this is good. I hope this is going to be also a cool presentation, what we have today. So as he said, my name is Jalton Ruiz. I'm engineering manager for the MicroK8s team. And yourself?
I'm Konstantinos, staff engineer at Canonical, working on the MicroK8s project.
And we are going to talk about the complexity of running Kubernetes on the edge and on the IoT. So before starting, I would like to make some questions. So if you know the answer, raise your hand. How many of you know what is Ubuntu? Okay, trivial question, right? It is everyone. And how many of you knows what is Canonical? Most of you. And how many of you knows what is MicroK8s? Only few. And that's the reason why we are here today. Because we have a solution for Kubernetes on the edge, but this is not well known on the open source community. And we are trying to promote this and encourage people not only to know, to use it, and to contribute to that. So some facts starting about MicroK8s. So we started in 2018. So it is going to be 5 years already of this product. We have like 115,000 deployments every month. One of our goals is to have the MicroK8s release 24 hours after the CNCF release. So this is the maximum that we can release MicroK8s. Meaning that if we have a release from CNCF today, in the same day or early the next day, we are going to have a release of MicroK8s. And that is useful that people who are using MicroK8s with all the advantages this is bringing, that they can enjoy the features coming in the CNCF release right after it is released. And one more thing that I would like to mention, we are pioneers on the cluster API deployment. So cluster API is perceived to manage like big number of clusters. So it is exactly the case of the use case for the edge devices, that you have a centralized cluster, and from there you need to do lifecycle management and provisioning of many clusters out there in the field. This is the two products that we have in Canonical today related to Kubernetes. So this is a CHAM Kubernetes. This is a solution that is designed for big data places, so including a lot of CNI, CSI, CRIs. It is a model-driven Kubernetes, so there is a lot of simplification on how to use the Kubernetes when you are using CHAM Kubernetes, but this is not what we are going to cover today. So today we are going to cover MicroK8s. And just to mention a few things about MicroK8s, it is a lightweight Kubernetes, so we can fit in those places that there is a physical resource limitation like CPU or memory or disk. Despite it is small, we are supporting all Kubernetes services and all Kubernetes API. It is getting high availability by default, and then we have automatic upgrades and updates. So especially updates, when we talk about vulnerabilities, those are happening on the background. So those are the list of challenges that in discussing with the community, in discussing with our customers, that we see related to deploying in the edge. So the first one is we need to have out-of-the-box security. So there is no an environment that is 100% secure, but we try to have a set of features that we can comply with certain security regulation and certain security standards. So reliability, most of the devices out there in the field, they need to be reliable in a way that no one needs to do any kind of maintenance, any kind of troubleshooting. So the more the device is alive, the better for us. Cost reduction, this is very important, especially when we talk about the edge devices. So if in one cluster we reduce 10 euros, for example, when we are talking about 1,000 clusters that we are deploying, so then this small reduction in one cluster is multiplying by the number of clusters. So that's why the cost reduction is important. Another thing that we have in mind when designing the MicroK8s is that we need to bring to the people the possibility that they start with small POC, and then with exactly the same, they can go to production. And I'm going to show some examples later. This is very nice. So how many of you believe that Kubernetes is easy to handle? It is a complex thing, right? So what we're showing here is some of the features that we have implemented in order to reduce the Kubernetes complexity or to make it easier for the user. And then we are going to end up with the hardware resources, where MicroK8s can be run and what is the compatibility. And at the end of all this, we are going to show some demos that we have recorded. OK, out-of-the-box security. So one of the visions from Canonical is that we are not talking about the security of a single layer of this. We are talking about security of the end-to-end of the whole stack. Infrastructure or Kubernetes is only a portion of this, but if you are interested in security on the full stack, we can arrange further discussions around that. So features that we have in security. So we have FIPS conformance in MicroK8s, and we are now working on getting this CIS conformance for the MicroK8s cluster. This will be ready in August this year in the release 128. Trivia operator, it is integrated with MicroK8s, so meaning that all this scanning from Trivia and also vulnerability analysis and conformance assessment, they are already integrated with MicroK8s, and you can enjoy that. And then one of the things that we are pushing for, it is the strict confinement, meaning that all the applications and the operating system, it is all packaged in a snap with a full isolation. We're going to see it in the next slide. So this one, this is a strict confinement where all the applications are running in snaps. For example, MicroK8 is also one of the applications, and then here you can have as many applications as you want, but there is fully isolation between two applications. And the same is applicable for the operating system. It's completely isolated. What's happening when they are isolated? And immutable, so it is more difficult to penetrate in terms of security. If you want to try MicroK8 on a strict confinement, so we have several channels. So this is the standard channel, the classic one. And then if you type like ---- strict, then you can have this strict confinement with snaps. And then this is another thing we have. It's not related to the edge, but we have it in the same slide. So you can run MicroK8 either with the Kubernetes from the CNCF on the background or using also AKSD. The advantage of this is that you can easily integrate your AKSD deployment on Amazon with the on-prem deployment utilizing the same add-ons from AWS. And now reliability.
So for reliability, I would like to focus on high availability that comes with MicroK8s out of the box. But before doing that, we need to first understand what high availability means to different actors on a Kubernetes cluster. So you see here a typical deployment of a Kubernetes cluster. You see we have the green part there that is the control plane, and then a couple of worker nodes over there. One of the actors that we have is, of course, the users. And HA for the users means that they can access their workloads that run on the worker nodes all the time without any disruptions, right? For the admin, high availability means something else. It means that as an admin, you need to always have the control plane accessible to you. And of course, you also need to have the workloads available to your users, right? So for that, you need multiple workers. You need to have the workloads spread across those worker nodes. And of course, you need to have a load balancer to drive the requests that the users do to the right worker nodes. And the state of the workloads need to be kept somewhere safe so that when a pod, for example, goes down, the state is not lost. So for that, you need a persistent storage layer. Okay. For the Kubernetes itself, things are a bit different. For Kubernetes, the load balancer, the persistent storage lives outside of the cluster. They are not interested. They're not interested to it. For the Kubernetes cluster, the services, the Kubernetes services, need to be always available. And of course, the state should resist any failures. The state of the cluster itself needs to resist any failures. And for that, you need a data store that is reliable. In the case of the default Kubernetes deployment, this is usually etcd. In MicroK8s, we have Digolite. So we deliver all this with MicroK8s, and we do so in a way that it requires zero ops. Okay, like you don't need to do anything in order to go into HA mode. You just need to join 3 nodes together to form a 3-node cluster, at least 3 nodes. But we said that for the users, you need to have multiple workers. So how do we solve this? These 3 nodes that you added are also the worker nodes. These nodes can serve workloads. For the administrator, we said that the control plane should always be available, right? So that means that these 3 nodes should also run the control plane. Okay? And the third part is that the state of the cluster should be kept in a way that can resist failures. Okay? And for that, we use distributed SQLite. That is a product from Canonical that's called Digolite. And the good thing about this is that transparently, node, it elects another leader, and the cluster is always available. So as soon as we have this very stable setup, on top of that, we can have a load balancer, for example, like MetalLB, that solves the load balancing problem. We can have a storage solution that distributes data blocks across the different nodes. Okay, so this is high availability in MicroK8s.
So this is, yeah.
Should I ask
Anytime.
Quick question regarding the high availability on an edge or something. So if I just have 3 nodes, how do I do the load balancing? So let's say they have 3 static IPs. So 3 static IP addresses on 3 nodes on an edge, yeah, somewhere in a whatever shop floor, for example. Do I need a hardware load balancer or something, or is there a smart mechanism? How can I make an app high available?
Okay, so what you practically need is a floating IP that will serve the workload. Okay. If you have a load balancer, an F5 or whatever, you can use that. If you don't have that, then you can use MetalLB and tell it, look, this is the set of IPs that I have available for you. So yes, you need something that some IP under which the workloads will be available from.
But it's floating.
Yes, it has to be, yeah.
Thank you.
If you have more questions, so we can catch up after the session. I wanted to say that high availability, how the cluster is getting high availability, we are going to demo at the end of the presentation. All right, cost reduction. So this is very important when you are running real devices that, it is used for any kind of enterprise or business development. So we see 4 factors that can impact on the cost reduction. So the first one is operations. And by operations, I mean, what is the time that an engineer takes to deploy a cluster, or how complex it is to deploy a cluster, or even how complex it is to deploy a big number of clusters. So what we have come through in order to alleviate this or to improve the efficiency when it comes to operation. So we have created something called the add-ons that I'm going to explain in the next slide. and then also launch configuration. So launch configuration means that you send the configuration to the cluster even before installing the MicroK8s, and when you install MicroK8s, it is already taking the configuration that you want, and including the images as well. For deploying massive number of clusters, so we have Juju or cluster API that we're going to check it later on the presentation. So another source of cost is obviously hardware and software. In our case, software, it is free to consume, it is open source, so you can go there and download the MicroK8s. And then one of the important things that we have in MicroK8s is that it is requiring minimal footprint on the hardware. So basically, it can fit in most of the hardware that the devices are having out there. Lifecycle management, it is very complex when it comes to Kubernetes in terms of updates and upgrades. In case of MicroK8s, the updates are happening automatically via Snap. And this is one of the things that we have in order to have a cluster secure, that we're making sure that whenever there is a vulnerability, this vulnerability is getting into the cluster that we have deployed. And the upgrades, Juju and Cluster API, those are the two lifecycle management that we have to run the upgrades. Enterprise support, this is maybe not really connected to open source, but when you want to have like enterprise support, we have Ubuntu Pro, which is bringing like a security, support 24/7 and compliance. And one thing on this type of business model is that you pay for Ubuntu Pro and for the infrastructure support, but then all the containers, all the devices that you get with MAS and the VMs that you can create are included in the same price. So we are not charging per the number of VMs or the number of containers. This is what I said before. This is the layout of the whole Kubernetes solution in Canonical. So here we have a Juju that is a model framework that we use in the whole Canonical to do lifecycle management and provisioning, not only of Kubernetes, so it is many more products in Canonical, but you can use it also for Kubernetes. And then we have Cluster API, which this is coming from the upstream collaboration. And basically, Cluster API, what it's giving is a possibility to do provisioning and lifecycle management of many clusters, but using this upstream component. We're going to have a closer look on Cluster API later on. So in summary, we have two ways to provision and do lifecycle management. We have two products, lightweight, and then the product for big data centers. And then basically, we are claiming that we can deploy our clusters everywhere. So we are supporting, obviously, the deployments on the main cloud providers like Amazon, Google, Azure, but many other more that you can see on our website. This is the concept of the add-on. So in order to activate an add-on, this is the command that we use. It is MicroK8s, enable, and then the name of the add-on. And right after this, the add-on should be up and running. The add-on could be a Kubernetes service, it could be an operator, or it could be a combination of them as well. So one example for any of these add-ons that you see here, you type like MicroK8s enable metal LB, and then it should be working out of the box. So it is simplifying a lot the configuration that you have to do manually in order to have one add-on working. We have three types of add-ons. So those are the core add-ons. So those are prepared by our team, and maintained by our team. We have the partners add-on. Those are collaboration that we have with different enterprises. And then community add-on, that it is when someone from the community is preparing their own add-on. One of the important things is that you can prepare your own. So when you know that you want to have something enabled and you want to simplify the process because someone else is going to use it, you can create your add-on, and then that other person can use MicroK8s enable add-on. We have a demo also today for that, but this one is taking longer, and I don't know if we are going to have time. If not, and you are interested in creating your own add-on, so we can take it later. So this is the edge features, and this is what I explained before, the launch configuration. So basically, you define the configuration that you want to have in the cluster here in the YAML file. You send this to the machine where you want to have the cluster, and when you are installing MicroK8s, it is coming up with the configuration that you want. So simplifying a lot the deployment of the cluster. But still, if you want to have a change in the configuration, once the cluster is deployed, it is also possible. When you are running on a strict confinement with the full isolation, it is also possible to send the configuration. The only thing is that we need to set to the to-snap, please connect these two, and then update the configuration. So this is one of the important things that we have in MicroK8s. So what we have here on the line, it is the way that the product is growing until it is going to production from the POC. And the requirements that we have in the POC are not the same requirements that you are going to have when the product is going to production. So in here, you are looking for minimum hardware, partial solution. You don't need to have the full solution, just to show that some feature is working. It needs to be completed within the days, so something that is quick, just to demo, and it needs to be free, or the freeware version. And then what you're looking for here, on the right side, is hardware optimization. We are not talking more about minimum hardware, because the hardware needs to comply to certain business needs, but it needs to be optimized in terms of cost. You need to have a full solution, which is thinking about the users, the encryption, so everything. But you need to have a Kubernetes that is supporting the full solution. And we are talking about things running for years. And then it needs to be scalable, and it needs to be stable, and then most probably this enterprise support. The good thing of MicroK8s is that if you start with MicroK8s, a POC over here, you can run it during all the phases of the product development until production. Because it is lightweight, you can use it even on your own PC to do a POC on a very small VM on any public cloud. It is fast to deploy, so it takes only minutes to have a cluster working. It is having, from the beginning, all Kubernetes services and API. And then when you are here in the production, this is still there, but we are adding the production grade, meaning that the product is stable, the product is scalable, the enterprise support with the Ubuntu support, and then you don't want to have any licensing, so this product is free, that you can use it also in production environments.
Okay, let's talk a bit about complexity. The complexity in Kubernetes can explode, especially when you think that you very often do not need a single Kubernetes cluster. You don't need to learn about the details of setting up a single Kubernetes cluster, but you may need 1,000 Kubernetes clusters on the edge. Okay. So in order to handle this complexity effectively, you need some kind of lifecycle management. And what is proposed upstream is what is called cluster API. What is cluster API? Cluster API is the view of the Kubernetes community, how software in general should be deployed. And in this particular case, how Kubernetes itself should be deployed and managed. So what does it do? Cluster API essentially maps the concepts of Kubernetes itself into Kubernetes resources that live inside Kubernetes. And then it applies on top of it the operator pattern, the controller, agent, call it what you want, this pattern, where basically the user specifies the end goal, how I want my infrastructure to look like at the end. There is a reconcile loop that checks all the time what is the current state of my setup and tries to slowly apply the changes required in order to get from the current state to the goal that the user has specified. Okay. And by doing so, essentially you add features like scaling. You can say, I don't need 4 worker nodes now, I need 10. The cluster API will make sure that more worker nodes will be provisioned, they will join the cluster and all these things. Other features, self-healing. Okay, let's say you lose a node. You don't see it immediately, but cluster API is always there checking, do I have all my control planes up? If not, let me provision a new one. Okay, self-healing. Easy cluster upgrades. You don't go on every node separately, SSH there, update the binaries. Like, no, you don't do that. You go into the manifest, the specification of the cluster, and you say, okay, I know it was 126. I'm changing the number now to 127, commit it again, and then Cluster API knows how to upgrade your cluster. Okay. So, as we've said, the user is the one that creates the cluster specification. Okay. This cluster specification is read by a few providers. There is a provider that provisions the infrastructure provider. There are other providers that take care of bootstrapping the node and managing the control plane itself. And as soon as and of course these providers are there because they take care, they monitor different resources. Okay, like the infrastructure provider, for example, takes care of the machines, that the machines can be provisioned from a different set of clouds, a different set of sources where VMs or physical nodes can be drawn from. Control plane provision providers and bootstrap providers are the ones that are going to provision you the Kubernetes cluster. We have two provisioners that will provide you MicroK8s. Upstream is also, in upstream you will also find provisioners for Amazon Elastic Kubernetes Service, kubeadm, and Talos. Okay. So what do we do that is, what does MicroK8s do? These provisioners do that very much align with the concept of edge devices. Normally, when you do upgrades, the upgrades happen in a way that one node of the old version is decommissioned, and a new one is provisioned with the new version. And slowly, this process repeats until the entire cluster gets upgraded to the new version. Of course, you understand this may be problematic in the cases of edge deployments where resources are scarce. Like you have these specific 3 machines. You cannot provision anymore, right? So with MicroK8s, we have implemented an upgrade strategy that does upgrading of nodes in place. It's faster and it requires less resources. Of course, the normal rollout upgrades of replacing nodes is also available. Last topic that we are going to discuss is hardware resources. MicroK8s at this point is available on these architectures. AMD64, ARM64 are supported. PowerPC and S390X are available. We have also builds for those. The cool thing about MicroK8s is that it is a snap, and as a snap, it is essentially, you can see it as a fat package that brings Kubernetes plus all of its dependencies together. And that means that we can very easily and reliably support new architectures as we decide. The hardware requirements that we have, you can run MicroK8s in 1 gigabyte in a machine with 1 core and 1 gigabyte of memory, but the experience will not be great. So we recommend that you use at least 2 cores, give it 4 gigabytes of memory so that you have space for your workloads. Another thing that is interesting is how easy it is to support new hardware. A good example of this is the support for the NVIDIA GPUs. By essentially doing MicroK8s-enabled GPU, you get on your host machine the NVIDIA drivers installed, CUDA runtime, and everything else that needs to be there in order for GPU-enabled workloads to run effectively. Okay, demo time. We have prepared pre-recorded 3 demos. I'm going to start with this because I was a bit surprised by your answer that it is hard to set up Kubernetes. Okay. So what we're showing you here is a cluster of how you create a cluster of 3 nodes. These 3 nodes are just VMs running on my laptop. Okay. And you see here the first command is sudo snap install MicroK8s ---- classic. This is the only thing that you need to do in order to have Kubernetes running on your machine. Okay. We repeat the same process for the other 2 machines, so that we end up into a setup where you have 3 separate clusters running on 3 separate VMs. Okay. As soon as we are done with that, we need to somehow join them into a cluster. Something else here. You see that MicroK8s, we said that it is a fat package. It brings everything together. So here you see one command that says MicroK8s kube control get pods of all network namespaces. Yes, with MicroK8s you get kube control. Okay, it's behind the MicroK8s command here, so you don't need to install anything extra. In this specific demo, what we're doing here is we're waiting essentially for the 3 nodes to come up. Of course, Calico, the CNI that we run by default, needs to be up. You see it here on the first node. It's coming up on the third one, on the second one, yes. And then we will move to the third one. Okay. So next thing that we want to do is to join these nodes into a single cluster. In order to do that, we go into any of those and we do MicroK8s add node. Okay. With MicroK8s add node, you get back what you need to punch into the other nodes in order to connect. Here it says you have to go into the other node, do MicroK8s join, and give in this connection string. Okay, it's over here. Okay, and what we're doing here is on the first node here, we do a get node. We're waiting for the nodes to join. The second, on the second node where we have punched in this, put in this command, is now waiting for the node to finish joining the cluster, and very soon we will see it coming. So note that at this point, the nodes join as full nodes with control plane on everything and everything. If you don't want to run the control plane, there is a ---- worker flag, and in that case, the cluster will join, but it will not run the control plane. It will not play any role in high availability. Okay. Here we're also demoing high availability. Okay, so the second node came in, and we also need to join the third node. Same process, go into one of the nodes, do MicroK8s add node, take this connection string, put it on the third node. Okay, and while we're doing that, we're gonna check the MicroK8 status command, MicroK8 status, and see what happens here. Here we see that it reports that high availability is no, and my data store, where Kubernetes itself stores its state, it only runs on one of the nodes. Okay, it's only replicated, this state is only replicated in one of the nodes. Very soon, you will see that this state has been replicated in that second node here. Okay, still no high availability because we have only 2 nodes. We see the third node coming in, and very soon you will see that the state will be replicated in all 3 nodes, and high availability will turn on here. Okay. Now, of course, you don't believe me, so we will go into the shell. We will stop the first node, this one. Okay, and we will see what happens. Here we see, come on, stopping cell. Okay, now we're going to the unit 3 here, and we're watching Kubernetes, kube control, get no. We should see here that for some period of time, Kubernetes, yes, it's missing heartbeats from unit 1, okay, but still thinks that this might be something temporary. So the node is not yet marked as not ready. After a few seconds, Kubernetes figures out that unit 1 is not ready. And of course, in order to recover from this, you have to go and restart the machine, the machine that we just stopped, right? So if we do that, this recording did not go very well. There are some artifacts here. Yeah, but as soon as we did that, the unit 1 became ready again. Okay. I think, should we do another, should we take questions?
We have 8 minutes.
Are there any questions? Or if you don't, we can spend 5 more minutes to look at another demo. Okay?
It was too easy. There are no questions.
It is too easy, yes. Okay. Launch configurations. So what are launch configurations? Launch configurations are essentially a way for you to automate the deployment without actually sitting behind the terminal and doing stuff. Okay. So here, for example, I'm showing you the installation process. Snap install MicroK8s ---- classic, and I want version 1.27. Okay. As soon as this finishes, normally what you would do is check the status with wait ready to get all the pods running. And as soon as the pods are actually running, you see here we have core DNS and Calico, the CNI. What we need to do is to, in this example, disable DNS. We don't need the DNS that comes with MicroK8s, but we need to enable, for example, Metal LB and Ingress. So in order to do that, we do MicroK8s disable DNS. Okay, and then MicroK8s enable Ingress. You see it here. And we also need to do MicroK8s enable metrics server. Metrics server. Okay. What happens here is that essentially we have applied the manifest, the proper manifest to get these services up and running. And after a few minutes, we see pods are coming up, pods are created, and everything. And we are here at the place where we want to be. This, what you've seen, is a manual process. Normally, when you do multiple deployments, you don't want to go through this. You need to somehow specify this is what I want to happen on a deployment. How do you do that? You essentially, here I'm doing the removal, purge. You're essentially creating a manifest. In this case, it's the lc.yaml. And in this manifest, you say that I want only from the add-ons enabled ingress and metric server. Okay. What do we do there? What do we do afterwards? We put this file under root. This is one of the places where MicroK8s will look at when it gets deployed. It will take care, or it will read that file, and at the end, this happens during installation, and at the end, you will get the deployment that we just saw, that we just created manually before. So this is installed, and if we do get all, the service just starts. We now see only the Kubernetes service. Pods are coming up. Here we see the metric server is, the service is up. And now the pods come starting up, Calico, Nginx ingress, metric servers, and very soon you will see that everything is up and running. The cool thing about this is that we essentially automated what the manual process in a YAML script, in a YAML description, and we done the installation. I don't think we should go to the third demo. There's no time. So the third demo, if you want, we can show it to you after this. It's very interesting. It's how you can create your own MicroK8s enabled foo, whatever the foo integration is.
Whatever the last slide that we have.
Yes.
So just if you are interested in MicroK8s or using that for your own deployments, so where to find us? So in the MicroK8s.io website or also in Ubuntu Kubernetes. So we have a Slack group that we are attending or discussing with people over there, Slack MicroK8s. We are sharing sessions every 2 weeks, and then the calendar is here in the meetup group for MicroK8s. And then if you want to discuss with us over the camera, not face-to-face, so we have a community sync that we open up for everyone who is interested in this, open discussions. And it is the developers from MicroK8s who are in this community sync, so feel free to join us. It is every Friday, 1:30 GMT, and this is a link to participate in the session. And with that, we conclude the whole thing. So any question or?
Thanks for the presentation. Is there any way to use this not as a snap?
I think you know the answer in advance, right? The answer is well known. No for now. We will see in the future, but for now it is all packaged in Snap.
So the Snap is like if you try to put MicroK8s in something that's not a Snap, it's not going to be MicroK8s. Like there are stuff that just do not happen outside of the Snap world.
One thing I want to mention related to this, because I know some people, they don't like a Snap, but when you have 1,000 clusters, and then we saw in the previous presentations about security, that the time it takes from the security patch until this is already there, it is normally long. When you have 1,000 devices out there, you want to have these updates pretty frequently. And then in the way we have it, and then we are talking maybe about every 2 weeks, we do an update, so it is done via Snap. So for having, in my view at least, for having like 1,000 clusters, so Snap is bringing a lot of advantages, in my opinion.
If you have the opportunity to ship a software under a packaging that, okay, I'm not going to say snaps, under a packaging that offers the same functionality as the snaps, you should definitely go with that option and not try to ship it with, I don't know, any other means, okay? Yes?
And the tooling that I need in order to manage, let's say, 1,000 clusters. Yeah. So I mean, we have not touched it, but I know there are other tools like Rancher or something. Is this tooling also open source, or is this then limited to enterprise?
What tooling? The cluster API? Yeah, of course. It's open source. So everything is open source. Everything that Canonical does is open source.
Awesome.
Yeah, and also Cluster API, it's not a canonical product. It's from upstream. We just use it in order to provision Kubernetes clusters.
Maybe I go into Snap again here, but I think Snap is really nice for like desktop, if you have a laptop and updates come in. But for servers, I don't want this thing to be updated on a Friday afternoon.
So, okay. Look. I get it. It does not happen anywhere in the world that software does not get updated. Okay, like Android phones, iPhones that run in billions of people. Okay, they upgrade by themselves. Microsoft Windows, they get upgrades. Like this is something that is very crucial for the software industry. You cannot say I don't want something to be not to be upgraded. Yes, we can take it offline. But if you still don't want to upgrades to happen, there is an option to say freeze updates, hold this, and it will never upgrade. Okay, it is an option. Okay, yes, let's take it offline. I don't agree with this. Yes.
Thank you very much.
Thank you.